let me give you a little bit of the background to this talk. So I am a kind of a regular with Beam. I had a long-standing interest in Erlang. 100,000 years ago, I was working for a now defunct large telecoms provider. And my very first job on graduating was working on a multi-processor system and converting our single-threaded, single-processor code to a multi-processor platform. And how we did it, we had this amazing Heath Robinson arrangement, which involved the operating system having all kinds of rules about processes, you know, their priority and what happens if it's raining and stuff like that. And as that was going on, we would hear these stories about what was going on at Ericsson, who were one of our peers. And it was very much a case of, wow, if only we had something like that Erlang, then it would be so much easier and make so much more sense. So I started working with Beam maybe kind of early 2000s. I was introduced to Francesco by my tutor. I was on the software engineering program at the time, and I you know, kind of fell in love. It's really been an interesting to see how the ecosystem has grown over all these years. Now, I fear that some bits are not going to come back, so I'm gonna curtail it and let me go with what we've got, because the truth is, as we started, so this began as a conversation that I had with some of the guys at Erlang Solutions. Now, as an academic, I see a lot of different things, a lot of different platforms, and I have been for a while trying to introduce mainframe people to Erlang and Erlang people to mainframes with varying degrees of success. So I'm hoping maybe this could be the start of something, and perhaps I could interest these two communities in some additional interaction. So I think the best bit is gonna actually come now, and if I go sherry, I hope you like my background. Does anybody know what that is? Answers in the comments, please. Anybody recognize that? What do they think that might be? Bear in mind, I can't see the comments at the moment.
So we've got chat is disabled on Zoom for these sessions, but there is the chat running on the Hoover Code Mesh virtual conference platform. So comments, suggestions, guesses as to what Herbert's background is there, drop them in there.
I am going to put you out of your misery. So that is the control room for something called Project Cybersyn, which was developed by a guy called Stafford Beer, a cyberneticist. Some of you may have heard of him, but I find when I talk to students now, that's a kind of a history that's kind of lapsed. And he was working for the Allende government in Chile, and he had this project to try and monitor the whole economy and to kind of you know, balance supply and demand. And one of the things he had at the center of it was an IBM 360 mainframe. So we know that particular project had a short-lived history, all because of a person called General Pinochet, but it was an interesting application of large-scale computing nonetheless, and this was kind of in the early 70s. So, I think you can see. A picture now. A funny thing happened on the way to the future. Yeah, good stuff. Okay, So, my name's Herb. I am an academic. In previous lives, as I was saying, I've been a software engineer. I've been interested in modeling systems, so understanding the performance and capacity features of them. And that led me to work with a group called the UKCMG, so the Computer Measurement Group. Now, some of the people I have spoken to about this go, once they figure it out, and if you Google not UKCMG but CMG, which is kind of the global kind of version, they've kind of gone, oh yeah, that's velocity only for ops and boomers, right? So it was a group that kind of look at the software once it's actually developed and think about how the performance and capacity can be monitored and improved. And so this had kind of continued a theme that had been running through my career. You know, how do we get performance out of systems, and concurrency being the kind of the design version of performance and capacity. Why this topic and why now? So I am a Janus-faced academic honeybee in the sense that I look at lots of different technologies and lots of different ideas, and there are some benefits to being an academic. You know, people would convince you otherwise, but no, you can enjoy yourself a little. And one of the things I enjoy is being a pollinator. So going between different communities and seeing what's on their mind and trying to kind of create the connections that will help them solve some of the problems that they have. So several times I've had conversations with people in the Beam community, and I've said, do you know much about mainframes? And they've gone, really? Why would you want to know about those? Yeah, we know everything we want to know about those ugly things. And similarly, I've had conversations with the mainframe community, and they say, what that t-shirt stuff, that kind of beard and sandal stuff that people do, you know, we wouldn't trust that on our enterprise systems. But meeting both sides, I see so many similarities and so much potential synergy. I thought it's definitely worth kind of having the conversation and see if there's something that we couldn't do to bridge the gaps. So I do believe that mainframes are alternative tech, even though they have a reputation for being kind of fairly corporate as such, and that is somewhat deserved. Large-scale enterprise systems tend to be owned by well-established organizations that have a lot of kind of let's say history. But the interesting overlap that I found is in terms of how the types of problems that mainframes are trying to solve and the types of problems that people on the Beam platform have lent themselves to have so much overlap. And what's more, the world that they live in are actually converging. So whereas before they've often been separate little ecosystems, as the world of tech changes, I see more and more opportunities for them to work together, whether they like it or not. Bang. So by way of full disclosure, I am an academic. I work for the University of Wolverhampton. For my many sins, mostly involving tempting the young into trying mainframes, IBM have made me an IBM champion. So I don't get paid, but through free t-shirts, indirectly they clothe my family. You know, any given time of day, you will see a member of my family walking up and downstairs wearing an IBM t-shirt or other. So a lot of my knowledge and understanding comes from working with the platform over, say, you know, nearly 10 years now, and attending conferences and tribal gatherings for mainframers, and hearing their stories and looking at their tech and trying stuff out on the platform. So let me give you the punchline. Why do mainframes still matter? There's basically 5 things about why you should care, why you should be interested. And as I was developing this, and I was talking to my friends, and we were getting some back and forth on this, it occurred to me that actually maybe each topic deserved a talk, because there's that much of a story to tell. But basically, in the first place, you have the heritage. So the type of systems that we're talking about, and I'll say something about the origin of the term and the particular systems I'm going to look at in a second. This was where computing as we know it came from. So a lot of the ideas that we're talking about now, mainframe people were maybe talking about 30, 40 years ago, right? And a lot of fundamental things that we talk about, particularly in software engineering, where they come from, the stories, those are mainframe stories. So they matter because they were often our when I say our, I mean software engineers' kind of first attempts to build really large systems that scaled. And a lot of the lessons that we have from those experiences are relevant today. They are very much at the center of global critical infrastructure for large companies. So anytime you go to an ATM, anytime you get a credit report generated, anytime you do an online payment, somewhere you are spinning the wheels of a mainframe. So people imagine, yeah, I'm not beam people because they're very tech savvy, but a lot of the people imagine, okay, I'm accessing things on my phone. Actually, what's serving up that information, what's managing your account, is a mainframe somewhere. Especially if you're, banking, insurance, all that good stuff. You might see it through the web, but ultimately, at the core, there's a mainframe doing the heavy lifting. We have seen the ability of mainframes to adapt to changing needs. So when I was an undergraduate, when we were reading textbooks, if it mentioned mainframes, basically we skipped that chapter, right? Because we thought, well, okay, that's not a world that is current. But increasingly, if you want to get involved with some of the really interesting work that's going on, and a few years ago, I had a student who was in his second year get chased down and pulled into industry because the internship on a mainframe project that we put him through meant that he'd been working on blockchain systems on Hyperledger before version 1 came out. So there are lots of cutting edge applications for these kinds of things, and the platform has adapted to make itself more relevant. It matters because as time goes by, systems are converging, right? So the hybrid cloud, I mean, maybe I think late 2000, so kind of like 2008 or so, everyone I knew was kind of talking about how they were going to move to the cloud and how they were going to save lots of money and how they were going to eliminate all these servers. And at the time, a lot of people that I knew in the industry were saying, well, but okay, how are you going to control costs? How are you going to consolidate that? How are you going to move between, kind of platforms when you need to? And all those things they talked about have come to pass. And so as we look at hybridization in the cloud, about having our own private clouds and using certain metered services for certain types of applications. The worlds are coming together, and this is the big thing. Mainframes have very much embraced open source. So back in, I believe it was 2000, 2001, there was the first project run out of the Böblingen lab in Germany to port Linux to a mainframe architecture. And that has now grown to the extent that we have all Linux mainframes. But that's a story that we'll get to. Okay, so when I say a mainframe, what do I mean? Now, over time, there have been many different families of mainframe. In fact, at one point, it was almost a kind of a national thing. So the French had Bull, and we had ICL, and the Americans had several. But when I'm talking about mainframes, I'm talking particularly about the IBM 360 family and its derivatives. So 1964, IBM, who are a big tech company who had lots of government contracts, effectively bet the farm on coming up with a general purpose enterprise machine that was going to go to big corporations, and they were going to kind of use it as a utility, kind of very much the same way they use kind of heating and lighting. This was going to be their general solution for calculations and computing. So that went quite well, and this is how IBM becomes synonymous with computing, perhaps in the 70s, to the extent that it's kind of very much seen as an incumbent, and all the newbies snapping at their heels, like Apple, kind of view them as an antagonist, almost in the way that Apple is viewed as an antagonist to many small companies today. But if we have a look at some of these pictures here, right on the left, this is the original 360, and it's gone through a variety of iterations to what we have today, which is the Z15 now. Sometimes it's funny how they count. You start with 360 and you end up at 15. Now, just to explain, the frame in the mainframe literally refers to the iron kind of box that you used to hang the components in. Right? So effectively, we're really talking about a rack, right? So a frame is effectively a rack. And this kind of hints at the relationship between what we would think of as racks of servers now, which are now cards, and what the mainframe does itself. So you're effectively talking about a data center in a box, right? So not quite the same in terms of the hardware that it uses, but in terms of the utility and the principles and how it works, that's essentially what you're looking at. And of course, the design points here. It was designed for high capacity transaction processing, because in the enterprise space, that's what really makes the difference. So how many payments you can process, how many records you can access, how many you can turn around, and this became central to banks, to airlines, and all kinds of other groups who who were kind of mission critical and for whom failure was not an option. So a lot of the design points that you see around the inside of it, they lean towards scalability. 5.9's availability has been a goal, and this is since the 60s, and they achieve this. And it's also highly configurable. So it's a resource that has been virtualized since the early mid-80s, and partly because of some of the quirks of how we charge for mainframe software, there's always been the incentive to try and run it to full capacity. So the notion of having a mainframe and having lots of spare cycles was never something that people wanted to do. Now, doesn't that sound interesting? I often say to some of my students, it's the biggest platform that you've never heard of. You know, it's everywhere, you use it all the time, but no one really knows what it's about unless you're in that world, unless you're part of that ecosystem. So if we have a look inside the latest one, this is Z15, and this was released around this time last year. So the one that I showed you before, that kind of single finger one on the right there, this can be extended up to 4 of those frames, and those are 19-inch racks, same as you'd find in a normal data center. The Z15 is the first of the family that has that that form factor. Previously, some of the others were a bit broader, but it's kind of an indication of how close the worlds are coming together, that they feel it's worthwhile coming up with something that would fit into the space for any other kind of rack. So when these are actually fully loaded, so to speak, they have up to 190 processors in them. They have up to 40 terabytes of RAM. They also have dedicated I/O processors. So these are processors that and all they do is I/O. And they can be divided into 85 LPARs, so what we call logical partitions, which again can be subdivided to run like multiple instances of an operating system. So I guess if you know your hardware specs from your data center, as one box, they sound pretty capable, and this is what they are now. This is a modern system. So this was one of the ones that I wanted to get into a bit more, but I think we choked part of it. So the chips that they use, one of those up to 190, is what we call an S390X. Now, it's possible that you, on your favorite open source project, you've seen the x86 target, you've seen the PowerPC target, you've seen the ARM various targets, and you see this S390X. What in the world is that? Well, basically that is a mainframe chip. They have 12 cores on them, and of course we have 190 of them inside the inside a big old Z15. One of the special adaptations that it has for enterprise computing, as opposed to the kind of the raw processing type applications, is big old amounts of cache. So a lot of the time it's fetching data, processing data, and slamming it back again. And that's where having a bigger cache makes a lot of difference. So it is designed for enterprise applications. It runs at, I think it's 5.2 gigahertz now. That they've fluctuated a bit. I think they found at 5 gigahertz you had some effects that made them slightly less efficient, and so they actually brought them back down a little bit. But those are backwards compatible in terms of instruction set with those first IBM 360s, because one of the things that made the initial launch such a success was that IBM promised that once you had your software written, you would be able to rely on it being supported and you being able to keep the software that you had written not quite in perpetuity, but quite a long time. Now this has had both positive and negative consequences, as we'll discuss. And this a lot of this is why we have the kind of the impression that we have when we sit down and talk about the platform. Now, as I say, as an academic, I see a lot of different platforms. So I know the functional programming world, and I know people on Beam. I know people that are into Java and C# and Python and that kind of thing. And I know mainframe people as well. And it's interesting how the cultures differ. But one of the things that you will probably hear if you talk to almost anyone in tech who is not a mainframer, I say mainframe, you say legacy. And it happened to me a couple of times. You know, I've even once been having an interview at quite a fancy university, and they said, you know, so what kind of industry contacts could you bring to this project? I said, oh well, you know, I've got quite good links with the mainframe community, and the interviewer actually laughed. Clearly it wasn't to be. So some of these terms you will hear about mainframes, and we have this concept of legaciness. What that even means, though, is something that we might want to unpack. So generally, and often with the best intentions in the world, when my Beam friends say, but surely that is legacy, what they're trying to say is, well, that stuff is A, outdated, it is B, proprietary, so it's like a kind of a walled garden and it's very hard to get in, and there's paywalls and you know, all this good stuff. Legacy in the sense of sometimes, like, you know, career suicide, is that really something I want to get involved in? And potentially, and this is partly due to a lot of the stories, operational risk or even technical debt is another term that you hear about it. But of course, this is kind of looking at it with a particular set of eyes and making a lot of assumptions about how the world should work. And often as software engineers, we can be guilty of you know, kind of looking for a perfect world rather than looking at the world as it is. I'm sure if you're on the functional program side, you'd have had these conversations with people who are convinced that OO is the only way of doing anything, and any kind of deviation of that makes no sense whatsoever. But of course, if you have the benefit of a kind of a broad education in computer science, you see why that's really not necessarily the case. So I might characterize some of the some of the issues that people have with mainframe and their legaciness. As number one, they are often incumbent systems. So you have large organizations who have often built up around the systems, and it's sometimes hard to tell where the organization begins and the system ends, if you see what I mean. So they often have practices and processes and other kind of features that are kind of, they're all meshed together. Because this was one of the earliest systems out there, it's often hard to unpick it. And because of our love of perfect worlds and our longing for kind of clean sheets, we look at the incumbency of mainframe systems and go, ooh, isn't that a bit gnarly and you know, yeah.
So you know, Herb, we got about 3 minutes left.
Oh, okay. Then I'm going to dash very quickly through some of these things. Well, get the idea about the legaciness. I'm just to say that the concept is a little bit socio-technical. So, you know, our train's legacy, well, they're the very best way to get freight from A to B. And in business, freight is essentially data. And so that's kind of what mainframes focus on. Oh dear. So let's just, I think that stuff is worth skipping. So essentially it's a survivor technology, and that's kind of why it looks the way it does. Some of the more interesting things about it are how it has embraced new trends as time's gone by, but at the same time can't catch a break. So this is some of the characteristic technology that people might know the platform for. This is JCL, Job Control Language, and this is how you tell a mainframe, this is what I want you to do. And there is a very tight coupling between the original punch cards and what goes into a JCL statement. So this is one of the reasons people look at them and go, ooh, what's that doing? What does all that mean? This is an example, and though this is not all they do, but there is a lot of this about. This is a little chunk of Cobol. Now, some of you with software engineering background would kind of think back to Edgar Dijkstra's quote about teaching Cobol should be made a crime. It cripples the mind. That said, there's a lot of it about, and it is involved in a lot of critical infrastructure. And when it goes wrong, there are big issues. And it's not as simple as people imagine, as in, you know, okay, let's just get rid of it and start again. There's reasons why we need it. I'm gonna skip some of those conversations. So I would. There was a big example this summer of there being a problem with some large Cobol systems, and a group got involved, part of the Linux Foundation, called the Open Mainframe project. And one of the things that I find really interesting about this world is they're a very strong community. People are on the platform. They are very good at looking after newcomers, and they're very good at sharing their knowledge inside their own groups, and in a way they're kind of marginalized in IT, and that to me makes them quite interesting. Thinking of where we are, I'm gonna skip to there is a whole ecosystem that is emerging around something called LinuxOne. So there are now all Linux mainframes that essentially allow you to provision about 3,000 kind of Linux instances. So again, essentially it's a data center in a box. And there's been this huge embracing of the open source movement. So this is part of the Linux Foundation. You can go out there, you can work on this stuff yourself. You can see how it works. And more and more tools and technologies that you recognize, like containers and Git and those kinds of things, have made their way onto the platform. So This was another thing, my central thesis, that there is a grand convergence because of what's happening with hybrid clouds, the fact that we have all Linux mainframes, and the fact that even the mainframes we have can run Linux in partitions. I would love to see more collaboration and investigation of what could happen in terms of other forms of alternative tech, but I think despite some of the differences and some of the history, mainframes deserve a place in the world of alternative tech too. And if this takes off, I'd love to talk about this again and maybe throw up some examples. I might just quickly say, if you want to go at some mainframe and playing around with them, there's something on at the moment called the the Master the Mainframe competition, and that allows you to go through some basic operations and teaches you about the platform. And it's basically there to encourage university students to get involved and try them out, because once people try them out, they tend to find, oh, that's a little bit interesting. If you're a student, it's actually a competition. If you aren't, it's just a learning system, and it will basically walk you through some of the basics of some of that ecosystem that I showed you, and also the crossover between other newer, fancier technologies. If you are a student, if you complete part 1, and we did quite a lot of it, our group last year, they will feed 2 children for a day through the UN World Food Programme. And we've had a lot of interest. We've had a lot of people get involved who otherwise mightn't, kind of humanities undergraduates saying, oh, go on then, I'll spend an hour learning about mainframes. And it's been quite an interesting experience.